Hi everyone. In this video, I'm going to discuss about the concept of generating list of prime numbers. Before going to discuss about the concept for generating the list of prime number, first of all, I'm going to define what is prime number. Prime number means that the number which is divisible by 1 and the same number, then the number is called as a prime number. It means that the number having the primary factor is 1 and the same number, then the number is called as a prime number. அதாவது ஒரு நம்பரை நம்ம பிரைம் நம்பர்னு சொல்றோம் அப்படின்னா அந்த நம்பர் ஒன்னாலையும் அதே நம்பரால மட்டும் டிவைட் ஆனாதான் அதை வந்து பிரைம் நம்பர் அப்படின்னு நம்ம சொல்லுவோம். சோ அப்போ ஒன்னை தவிர்த்து அந்த நம்பருக்கு வேற எந்த ஒரு ஃபேக்டருமே இல்லை அப்படின்னா தென் இட் வில் பி கால்ட் அஸ் அ பிரைம் நம்பர். இப்போ நார்மலா ஒரு ப்ரோக்ராம், ஸோ இப்போ நான் ஃபர்ஸ்ட் இனிஷியலா என்ன பண்ணலாம், ஒரு நம்பர் எடுத்துட்டு அந்த நம்பர் பிரைம் நம்பரா இல்லையா நம்ம செக் பண்ணலாம். ஸோ ஃபார் தட் just I'm going to take first I'm going to decide it is an integer. So I'm going to take the variable name is n. So variable name நம்ம என்னன்னு எடுத்துக்கிட்டேன். So already we know that logics வந்து define பண்றதுக்கு முன்னாடி take some sample example and you are going to define what it is. So அப்ப நம்ம n equal to 20 ன்னு எடுக்கிறேன். அப்ப நான் divisor நான் check பண்றேன். So that always I'm going to check it from 1. இப்போ 20 I'm going to check the remainder because நான் divisor check பண்ணா remainder check பண்ணனும். Remainder of the division வந்து 0வா இருந்துச்சு அப்படினா then 1 is the divisor. So here in this case அப்ப எல்லா நம்பருமே 1 ஆல டிவைட் ஆகும். So next C வந்து நான் modify பண்றேன், 2 ன்னு எடுத்துட்டு நான் செக் பண்றேன். So 20 modulo 2 it is equal to 0. So then 2 is the divisor. So 2ங்கிறது நமக்கு divisor தான். So like that I'm going to test it for 3 also. So I'm going to test it with 3. So 3 ஆல divide பண்றேன். So 3 is not equal to 0. So that it is not a divisor. Then I am test with 4. So I am testing with 4. So for the 20 modulo 4. So it is equal to 0. So that 4 is a divisor. So then I can try with 5. 5. So that 20 modulo 5. Sorry, small correction here. It is a 4. 20 modulo 5, it is also a divisor, remainder 0, so that it is also a factor. So next I can test with the 6. So 20 modulo 6, so it is not equal to 0, so that 6 is not a factor divisor. So the next thing is I can test with 7. So 20 modulo 7, it is not equal to 0. So that it is also not a divisor. Then I can test with 8. So 20 modulo 8. So it is not equal to 0. So it is also not a divisor. Then I can test with c equal to 9. So 20 modulo 9. So it is not equal to 0. So that it is also not a divisor. So next 20 modulo 10. So it is a 10. So it is equal to 0. So 10 is a divisor. So like that we have to test it for 11, 12, 20. But normally we have to test up to half of the number. After that we won't get any divisor. நமக்கு வந்து half of the number வரும் டெஸ்ட் பண்ணா போதும், அதுக்கப்புறம் நமக்கு divisor கிடைக்காது. But if you want, you can test with 19 also. See that the same logic is will repeat with this tested from 1, 2, 3, 4, 5, 6. But every number it is divisible by 2. But anyway, I am trying to start with 1 and I am going to try with up to n by 2. So and just I am going to write a code. I'm going to write a code without function. So initially I'm going to read our inputs. So that is the input. So getting input from the user. Okay, so next I'm going to test it with 1. Then while c less than or equal to n. So then I'm going to test it that if the value of n is modulo c equal to 0. If it is 0, just I'm going to count it that so that is equal to I'm going to count it number of factors. There are different ways we are going to write the logic. So just see here I'm going to count the number of factors. so that if the number of factor is, I mean that the number of factor is it's 1, then it will be in a reminder. I mean, so it will be in a prime number. Okay, just I'm going to display the value of s first, then we have to test it. So this is the logic to display how many number of factors we have. So just I'm going to run this code. I'm going to give that the input is 20. So for the 20, the factors are 1, 2, 4, 5, and 10. So totally there are 5 factors are there. Clear? Okay, so so that here just I can assume that if the value of n equal to 20, so the value of s is 5 factors. So assume n equal to 11. So just I'm going to run this code once again, and I'm going to give the 11. So that the value of s equal to 1 factor. I'm going to say n equal to 15. I'm going to run this code once again. I'm going to give the input as a 15. It says as it is a 3 because 1, 3, and 5 are the factors. I'm going to take n equal to 13. N equal to 13. So I'm going to run this code. So I'm going to say that 13. So it is 1. From that, we can easily say that if the number is a prime, we know that no 11 and 13 are prime number. So that if the value of if the factors are 1, then the number is called as a prime number. Here the factors which is stored inside of s. S will value the so that in case if s equal to 1, then I'm going to say that it is a prime number. So n is a prime number. I mean that it is a n is a prime number, or else. So already I told that just I'm going to write the logic for check whether the given number is prime number or not. So n is not a prime number. Okay, so just I'm going to test it now. So I'm going to give the 11. 11 is a prime number. I'm going to test 21. So 21 is not a prime number. I'm going to give 45. It is not a prime number. So this logic will works. Clear? Okay. So now what I need to do is just I can make this entire logic as a function with the help of with the arguments and with return. So def, I'm going to check the logic of prime number. So the input must be n. It's enough. I'm going to just copy this logic of everything here inside of the function. So this is the logical part of your logic part for checking the number is prime number or not. So I'm going to instead this, I'm going to return yes. I'm going to copy get the value from the function. Sorry, for passing a value of n, and I'm going to get the value of yes. The number of factors will be returned as an answer. So this is the logic we are going to implement the concept of prime number logic as a function. So I'm going to give that input as 21. So 21 is not a prime number. I'm going to give some other inputs. So for example, I'm going to give the input as 13. 13 is a prime number. So our logic works clearly. Clear? But sometimes maybe we can say like that, no? So by here instead of dividing a factor, even we can use the flag variables. Clear? So, but if you want to use a flag variable, the values of C must start with 2. இப்போ நான் flag variable concept use பண்ணனா வந்து C வந்து 2 ல ஆரம்பிக்கணும், and I'm going to say that is equal to 1. So if the value of s வந்து 1 ஆ இருந்துச்சு, assume that s equal to 0 ங்கிறது not a prime number assumption எடுத்திருக்கேன். So that வந்து நான் 2 ல இருந்து ஆரம்பிச்சேனா எந்த ஒரு நம்பருக்குமே அதாவது prime numberக்கு வந்து 2 ங்கிறது factor இருக்காது. 1 ங்கிறது எல்லா நம்பருமே 1 ஆல டிவைட் ஆகுது அப்படிங்கறதால நான் 1 எடுத்துக்கலாம். Just I'm going to give the random input. So 13. So 13 is not a prime number. So here I'm going to give that value of n so that it return as a yes. So that so if you are going to make it as a flag variable and it will work, So once it is divisible, then it will be an 1. Sorry. Yeah, this is the case. If I'm going to start with 2, then surely the value of s equal to 0, because for any cases this if part will not work. The if part வந்து எந்த ஒரு situationலயும் work ஆகாது. So that the 0 indicates that it is a prime number, and if this 1 indicates it's not a prime number, here I'm testing the condition for n prime number logics. So that just I'm going to give the value for 13. So 13 is a prime number. Just I'm going to run this code, and I'm going to give the 20. For example, 25. 25 is not a prime number. So this is the logic is also correct one. So this is for flagging. For flag concept வந்து கண்டிப்பா 2 ல இருந்து தான் ஆரம்பிக்கணும், because every number have the factor 1. So அதனால நீங்க 2 ல இருந்து ஆரம்பிச்சு தான் நீங்க flag indications பண்ணணும். Okay, 1. And the same thing is, or else for example I'm going to start with 2 and I don't want to break it. So here I'm going to say it is a break. So already you know break வந்து எப்போ work ஆகும் அப்படினா once the current loop விட்டு வெளியே வந்துரும். So இந்த loop விட்டு வெளியே வந்துரும். Here I'm going to say that if so already break இருக்குனா condition true ஆ தான் இருந்திருக்கும். So that return 0. இப்போ 0 னு indicate பண்றேன். That is for prime number. But c less than என்னன்னா இந்த condition still true ஆ இருக்கு. break ஆகனதான். break ஆகும் அப்படினா கண்டிப்பா divisible இருக்கணும். factor இருந்தாதான், so that I can return some other value. Else I return the value as for this case I don't need for yes. So இந்த இடத்துல எனக்கு s தேவை கிடையாது தான், but return 0. So இந்த இடத்துல sங்கிற கான்செப்ட் தேவையில்லை. I'm going to run this code and I'm going to give 13. So 13 is a prime number. Then again I'm going to run this code. For example 27. 27 is not a prime number. Clear? So this is the way we can work with the break also. Clear? And even and another one more thing, even if you want, we can try with up to n by 2 also. N by 2 also we can work. I'm going to run this code. So run this code, and this is for n by 2. So that here also there is a testing conditions must be changed, no? So int of n by 2. So now it's okay. I'm going to test with 13. So 13 is a prime number. For example, it is a 33. 37 is not a prime number. It will work for all the concepts. So you see that there are a different kind of logic we will discuss. Even if you don't want to function, you can just copy here, so that in a program 1, here I used the break concept, and for program 2, I use the concept. Instead of this break, I'm using flag variable. So for flag variable, I'm going to say initially 0. So here the condition a little bit changed. Just I'm going to return the value of yes. Return yes. So this is another one more logics. So this is for using flag concept. So if it is a flag concept, the value must be c value must start with 2. And for program 3, so I'm going to install that. I'm using counting principle, so that s equal to 0, and just I'm going to return the value of yes. So that s equal to s plus 1. So for the prime number, if it is s is greater than or for s equal to 1, then it is a prime number. Otherwise, it is not a prime number. For this case, s equal to 1. In case I don't want to start with 1, இப்போ என்னோட வேல்யூ வந்து 1 ல ஸ்டார்ட் ஆக தேவையில்லை அப்படின்னா, then for the program 4 case, c வந்து நான் 2 ல ஆரம்பிச்சிட்டேன் அப்படின்னா s must be 0 for a prime number, because 2 ல இருந்து எந்த ஒரு ஃபேக்டருமே இருக்காது. So these are the different logics discussed. One வந்து break யூஸ் பண்ணோம் அப்படின்னா இங்க conditions என்ன இருக்கோ அதே conditions இந்த இடத்துல நம்ம யூஸ் பண்ணிக்கலாம். So அதை பேஸ் பண்ணி we are indicating that it returns a 1, it is not a prime number, and it returns 1. 0 means it is a prime number. இது வந்து flag-ஓட கான்செப்ட். flag-ஓட கான்செப்ட் அப்படின்னா வந்துட்டு so that once இந்த if-குள்ள போகுச்சு அப்படின்னாவே flag-ஐ நான் மாத்திறேன். Initially assume that it is it's a prime number. So that prime number logic work ஆகுது. Next one வந்து start with C1 அப்படின்னா வந்து total number of factors. Here a logic is total number of factors. including 1 check பண்றது. So இங்க வந்து பாத்தீங்கன்னா program 4ல so total number of factors excluding 1. இது வந்து excluding 1ஐயும் நான் வந்து இதுல means excluding 1 consider பண்றாத லாஜிக்ஸ் இது. So sorry, here there is a correction that is called return yes. So return is, so here also return is. Okay, so this way we have to work with for prime numbers, but the question is list of prime number, so that we are going to take it the lower limit and as well as the upper limit. So in order to write the code for list of prime numbers, so for a list of prime numbers, for list of prime numbers, you are going to know what is the starting index. What is the start எந்த லொகேஷன்ல ஸ்டார்ட், எந்த நம்பர்ல இருந்து ஸ்டார்ட் பண்ணி எது வரையிலும் வர்க் பண்ண போறோம் டிஃபைன் பண்ண போறோம். So here enter the starting limit. Starting எதுல இருந்து பண்ண போறோம். So this is called start. I'm going to do a end. So indication of the ending limit. So ending limit not this வாங்கிட்டேன். So now I have to generate the range. ஒவ்வொரு நம்பரா நான் செக் பண்ணணும் from starting index ல இருந்து ending index வரணும். So that startல இருந்து ending index வரணும் ஒவ்வொன்றா நான் செக் பண்ண போறேன். that is n-1 வரைக்கும் தான் வரும். பட் எனக்கு end இன்க்ளூட் பண்றதுனால இந்த n+1 போட்டுட்டேன் அப்படின்னா end வரையில என்னால டெஸ்ட் பண்ண முடியும். I have to test it. வந்துட்டு I'm going to pass that value I தான். So I பாஸ் பண்றேன். Then I'm going to print it. Here is a prime தேவையில்லை, எனக்கு அந்த list of prime numbers மட்டும் generate பண்ணா போதும். else category எனக்கு தேவையே கிடையாது. So that just I'm going to remove this. இப்போ நான் வந்து else remove பண்ணிட்டேன். So for every cases இதுதான் work ஆகும். So just I'm going to pass the value and I'm going to display the value I. So just I'm going to run it. I'm going to give the starting limits as 10 and ending limits of 20, so that it will display the list of prime numbers from 10 to 20. So that it will display the value as 11, 13, 17 and 19. These are the prime number which is present from 10 to 20. So in case if I want to work with 10 to 100. So these are all prime number which is available from the 11 numbers from 11 to 10 to 100. So these are the numbers. These are the list of prime numbers. But here you can use a different logics, no? But actually here maybe somebody asking question that yeah else block use பண்ணலாம்னு. Question is this is a list of prime numbers, so that only we need a list of prime number now. Not a prime number பத்தி நம்ம worry பண்ணிக்க தேவையில்லை. So that just we can include everything. So list of prime numbers. So just I'm going to run it. I can give you 10 to 50. It shows the list of prime numbers from 10 to 50. So this is the way we are going to implement, means we are possible to implement the concept of list of prime numbers using function. Somebody is asking that I don't want to use the function. I want to use the function இல்லாம implement பண்ணனும் அப்படி நினைக்கலாம். இப்போ functions இல்லாம implement பண்ணனும் அப்படி நினைச்சீங்க அப்படினா then you can do the code like this. This is for program 1. இதுலயே நிறைய வேரியேஷன்ஸ் நீங்க கொண்டு வந்துக்கலாம். இந்த இடத்துல வந்து நான் பிரேக்ங்கற கான்செப்ட் யூஸ் பண்ணிருக்கேன். So the program இந்த கான்செப்ட் நான் யூஸ் பண்ணிருக்கேன். Or else you can use this program to இந்த லாஜிக்கை கொண்டு வந்து நீங்க இம்ப்ளிமென்ட் பண்ணிக்கலாம். இந்த இடத்துல நீங்க இம்ப்ளிமென்ட் பண்ணிக்கலாம். So that all four variations இதெல்லாம் நீங்க யூஸ் பண்ணிக்கலாம். Clear? Okay, so நான் வந்து without using functions நான் இம்ப்ளிமென்ட் பண்ண போறேன். So without using function concept நான் பண்ண போறேன். So without using functions concept பண்றேன் அப்படினா as usual the logics வந்து எப்படி இருக்கும் அப்படினா input வாங்கிருப்பீங்க. So here itself I am going to generate a logics. இந்த primeக்கு பதிலா primeக்கான கோட வந்து நான் ஜெனரேட் பண்ணனும். So primeக்கான கோட் வந்து இதுதான். So primeக்கான கோட இந்த இடத்துல நான் பேஸ்ட் பண்ணிட்டேன். So checking from a to break ஆகுது. Once I am going to remove this. அப்போ இந்த இடத்துல வர்க் ஆகும்போது there is just I can work it now. So just so in the cases கண்டிப்பா not a prime number, so that here instead of this So here there is no action, so it is pass. Pass means no action. This is else. For else case, I'm going to print or else. Clear? So if it is equal, so that if it is a greater, then there's less than or equal. So that if it is a greater, we can change. Okay, just now, just the way just we will work on it, and you can test it whether it's work or not. இது வந்து work ஆகுதான்னு check பண்ணலாம். Instead of this, okay, so just I'm going to take it as n. Okay, just I'm going to run this code. Yeah, sorry, function definitions need to be removed. Because the function concept in so getting upper limit and lower limit, and this is the logic for generating one number is a prime number or not, and it will be repeated. This logic for one number testing, and it will be repeated for from starting index to ending index. Means n value n limit work agudhu. For example, starting is 10 and it is a 20. Yeah, sorry, small corrections. I won't work. This is for n. So 10 and it is a 20, so that is generated like this. Or else I don't want to this pass and all. Just we can say that if the value of c is greater than integer of n by 2, then you can test it like this. The unwanted index is included, so yeah, so that it makes an error message. Yeah, sorry, here I'm going to print the value of n. If block is missing, so 10 and 20, it will display all the things. So these are the different possible ways we are going to implement. So this is the logic one, logic for without using function. This is program 1 for without using function. And for without using function, program 2, if I'm using c is less than or equal to, for this case, I don't want any action. So no need to any action means it is a pass. Else I'm going to print the value of s. So there are different kind of ways we are going to implement the concept of prime numbers. But only thing is you have to selecting what is the concept you are going to use it for testing a prime number. You have to implement it. Then you can return the corresponding methods. So based on that you can test it. But one thing is this is the list of prime numbers, so that the function to be invoked for n number of times for starting index to the ending index. So that without using function, with using function, is everything is correct for implementation of the prime number. Thank you.